Hello everyone, welcome to our channel Code with Sunny, and in this video I am going to talk about the problem find first and last position of element in sorted array. Index number is 3 and 4 and the problem is of medium type of LeetCode. I think this problem should not be categorized in medium type, and the reason behind this, once you get habituated with some special inbuilt functions in C++ or some other languages if you are using, then this problem becomes one much more easier to figure it out, the 2-3 line solution of this problem. Okay, so let's discuss this problem now. Given an array of integers nums sorted in ascending order, and this is going to benefit us, find the starting and ending positions of a given target value, and if target is not found in this array, then we have to return a pair -1 comma -1. Otherwise, if there is some element whose value is going to be equal to the target, find its first occurrence and this last occurrence in the given array. Note that we have to return the indices. Okay, like suppose we have this element 5 double 7 double 8 and 10. Okay, so elements are like 5 double 7 double 8 and 10, and target is going to be like 8. Okay, and we need to search for 8. Okay, you can see 8 is present over here and 8 is also present over here. What is the first occurrence of 8? It is nothing but this one. And what is its index? You can easily see if I'm using a zero based indexing, my first index of it is coming out at 3, 0, 1, 2, and 3. And what is my last occurrence index of this 8? You can see and it is coming out to be 4. I need to return this value, and you can easily see it is coming out to be 3 comma 4. Okay, and what about when target is not present? We have to return -1 comma -1. Okay, so let us try to find out how we are going to implement this in the best possible way. Okay, so if you are using a C++, okay, then there are some inbuilt functions of C++ HTL you can directly use. Okay, and let me talk about these functions. If you have been given some sorted array, note that I am going to use a sorted array. Sorted array term. Okay, if we have been given some sorted array, we have some binary search functions over there, and one of the function is like binary underscore search, and we have to pass up some parameters, that is beginning iterator comma ending iterator comma the target value, and this inbuilt function is going to return true or false, and it is going to just perform the binary search in log of n time complexity, where n is the size of the array, and it is going to perform the binary search and search if this target is going to be present in my array or not. Note that this function works only when the given array is going to be like sorted. Okay, so this array is sorted. This function is going to return true or false depending upon whether the target is going to be present in this array or not. I'm going to use this one also. And let us talk about some more functions of this inbuilt C++. That is, I'm going to talk about one of the functions like lower underscore bound, and this function is going to return the iterator, and this is parameter is going that argument is going to be passed like beginning position, ending position, and comma the element that I am going to find the lower bound, and this is going to return an iterator, itr, let's say auto iterator. Okay, and there is another function upper bound. Okay, this is inbuilt functions in C++ standard template library. Okay, upper bound, and the same thing is like beginning iterator, ending iterator, and the target value that I need to find. And let us try to understand what is this upper bound, this lower bound, and this upper bound. Okay, so suppose we have been given some sorted array, and we have to find what is the lower bound of some element and what is the upper bound of some element. Suppose we have been given some sorted array. Note that these two functions is going to work for the sorted array. Okay, so I'm going to write this. Okay, if we have been given some array like this, and we have to find it out, what is the lower bound of this tree? Lower bound means the very first position, the very first index where this element's occurrence is going to start, and it is going to return this index. That is, you can see if I am going to find out the lower bound of this tree, it is first occurrence is going to be 3, and this function is going to return the iterator of this position. Okay, and if we want to find the index, just return the iterator, that is, let's call the iterator this one minus this array dot begin, and it is going to be like giving the value of index. Okay, and the index is like 2. That is, if we find out the lower bound minus this array dot begin value, it is going to return this 2 value. And let us talk about this upper bound function. Upper bound function basically returns the iterator, which is going to be like strictly greater than the given target value. If this is the target value 3, if I am just finding out the upper bound of this 3, it is going to return this iterator, the iterator at this position. Note that the last occurrence of 3 is this one, and what is the just next occurrence after this 3? It is going to be 4. So this is going to return the iterator of this position. And if we need to find out the index of this position, just subtract this array dot begin value, same as in the case of lower bound. Okay. So what is my upper bound of this 3? My upper bound of this 3 is my this index, and what is the index of this one? And the index of this one is coming out to be 6. Okay, so we need to find the first occurrence and the last occurrence of the given target value. We can easily find the first occurrence using lower bound, and we can easily find the last occurrence also with the help of upper bound. And what is my value? This is, let's say the index coming through this lower bound is L1, and this index coming through the upper bound is L2. Then I need to just return the L1 comma L2 minus 1. Note that I am going to subtract 1 because this upper bound is going to give the index value just greater than my required answer. Okay, so let us try to implement this entire scenario in the coding part also. Okay, so I have this function. I need to just write it down some stuff. I'm just going to write down some 5 lines of code. Okay, so vector int answer, and it should be initialized with -1 comma -1, and let us try to search something, binary underscore search, and it should be like nums dot begin and nums dot end. And the target that we need to search, I need to pass the argument also. If this is going to return true, it is basically just signifying that yes, the given target is present. I need to just initialize answer of 0, that is modify answer of 0 and answer of 1. Answer of 0 is nothing but lower bound of this nums dot, that is lower bound of this target, and we need to first pass the beginning iterator, and let's first again pass the ending iterator and comma the target value that I need to search for that, and I need to subtract this the beginning iterator for getting the index of that. Okay, and what is my answer of 1? That is the last occurrence. Last occurrence is nothing but the upper bound of the same thing, -1. I need to take care for that also. Okay, and let me write it down, the target minus nums dot begin, but I need to subtract 1 to get the last occurrence, and after doing that I just need to return the answer, I think. Let's try to submit this code and check it out if this is going to be an efficient good solution or not. Yes, it is good. So this entire coding works in log of n time complexity, because you can see binary search is going to take log of n, and lower bound and upper bound is also going to take log of n. This is basically the one of the, you can also see the variations of this binary search to find some elements lower bound and upper bound. Okay, so if you have any doubts, do not forget to mention in the comment section of the video and let me know so that I can help you. And if you like this video, if you have just enjoyed or just got the concept, just try to like this video, share this video, and to subscribe to our YouTube channel for latest updates. Thank you for watching this video.